Today's topic is about networks. So we'll be discussing networks and some of the criteria necessary to have a network and the physical structure of the network or types of connection, and then ultimately we'll come to the topography of network, and then if time permits, then we will move on to network categories of networks. So the first question is, since we are going to talk about networks, then what is a network? Network is actually a set of devices, or sometimes these devices are also called nodes. Those nodes are connected by some kind of communication links. So devices which are being linked together to communicate or to send messages between the devices is what we call networks. In other words, computer networks. So these devices or nodes that is interconnected in a network can be a computer, it can be a printer, or some other devices which is capable of sending or receiving data on the network. And the communication link can be some kind of cable, or it can also be a wireless communication links, but links which are able to provide connection between those devices which we have just mentioned. That is what we call a network. Then one might wonder that why network is necessary. For example, one of the main reasons why network is necessary, that means why devices or nodes needs to be interconnected. The necessity arises from the fact that if the processing capacity of the computers are shared, then we have much more advantage than having the devices separately. So many years ago, we have mainframe computers. So you must have heard of mainframe computers. Okay. So these mainframe computers are usually computers which are, huge computers, which are standalone computers, which are not that powerful compared to modern day computers. So these mainframe computers are not that powerful. Now today, your mobile phone, it has much more processing capacity than the olden day mainframe computers. So what happened is that these mainframe computers were huge machines located in a computer house or a computer building where people go and get things done. And comparatively, as I said, it is very slow. The processing capacity is very slow. And it is a standalone computer. Then eventually people realize that these computers can be made faster, and the processors can be made smaller. Therefore, the computer becomes smaller. Then people also realize that if we have a community of, for example, a community of users here, then you have a community of users, or you have different users in different locations, then you interconnect them, you give them connection, you connect them together. Then what happens is that they can share their resources. They can share their hardware. For example, if this one has a printer, this printer can be shared. And at the same time, the combined processing capacity, okay, the processing capacity of the computers of this computer, 1, 2, 3, 4. If you combine all of this processing capacity, then it becomes much, much powerful. It is 4 times powerful than any of the single computers that we have. So that is why it is realized that, I mean, keeping a computer in a network has its own advantage. The other issue is that that led to uh, the use of the interconnection or the uh, formation of networks among computers is that people may be located in different places. Instead of using mails or instead of using courier services, then you can send data across the communication link. Then things are much faster. Things are much faster, and people can share their resources in a fraction of a second. So that is why this network was found to be necessary, and that is how we started. Now, what is distributed processing? As I've said, the task of processing is divided among multiple devices. For example, we may have this is located with a printer, so this can be a printer server. And for example, this is connected to the internet. We can have this one as a internet server, or we can simply combine the processing capacity of all of this thing and make them work like all these single devices, 4 devices work together like a single devices. So that is what we call it, distributed processing. That means the processing is being shared. Processing, this one serves as internet server, this one as printer server, this one serves as for example, the network server, or this one serve as the storage server, for example. Sorry. Yeah, this one can be the storage server. So, I mean, that way, instead of having all these things, serving the internet, being a print server, being a storage server, being a network server, I mean, confined to one computer, if this can be distributed among the devices in the network, then things can get much faster and more efficient. So that is why distributed processing is important and so popular in a computer network. So the task is divided among these devices. Instead of one large machine being responsible for all of the processing that we have already said, then each one of them can handle a subset of the processing. Now, there are certain criteria, okay, certain criteria in order to have a network. So criteria which is required to have a network. So here I have listed 3 criteria. The first one is performance. So one of the criteria is performance. So this performance can be measured in many ways. So one of them, one is transit time, and the other is the response time. How can you measure the performance of a network? It can be based on transit time or response time. Now, what happens is that transit time is the amount of time required for a message to travel from device to device. That means if a message have to go from point A, this device, to B devices, A device to B devices, how long does it take? Suppose if I send 1 MB file, how long does it take for this 1 MB file to reach B? So that is transit time. The other one, response time, is the time taken between inquiry and response. For example, I want to, let us say there are some files here in this B. So I'm using A devices to retrieve some files. So I send a request to B asking to retrieve some files. So how long does it take for B to respond and get back to A? That is what we call it response time. So the performance of a network depends on so many other factors. That means if you have the number of users, more number of users, chances are that network can slow down. Then it also depends on what type of medium, transmission medium you are using, because different transmission medium has different bandwidth capacity. The larger the bandwidth capacity, the faster it is. So it depends on that as well. And then it also depends on the hardware. So the devices, the hardware configuration, how fast is the hardware configuration. When you have more RAM space, you have more processing capacity, then of course that will lead to better performance. And then also software. The software that you use in a network can be efficient or it can be inefficient, or it can be slow, it can be fast. So many other things are there, in order to get the performance of the network. Now, usually performance are evaluated by two metrics. So the two metrics are what they call it, throughput and delay. Okay, so we often need more throughput and less delay. That means we want to send more files, as in this case here I'm sending 1 MB, and then if I send say 10 MB, okay, so I want this also as fast as when I send 1 MB, it should not be slower than that. So we want more throughput. Throughput means more. We want to send it as fast as more files or more MBs in a faster. In a much faster way. Now the problem is that when you are pushing more bigger files, okay, when you are sending bigger files, chances are that the delay will be more. Okay, so this is a very contradicting situation. More throughput automatically, naturally will be more delayed, but what we are trying to achieve is that more throughput but less delayed. So that is the ultimate goal of network performance, and that is how it is often measured. Then the next thing is reliability. The next criteria for the network is reliability. In addition to accuracy of delivery, reliability is measured by frequency of failure. How often the network fails, okay, frequency of failure. So what we want is that we want no failure. If that is not no failure, then it is reliable. And the other thing is that even if at all it fails, then how long does it take for the network to recover from failure? So that is how reliability is measured. And the third thing is security. Network security issues include so many things, like the protection of data from unauthorized access, then the protection of data from damage and other things, then policies and procedure for recovery, and so on, for data loss and all. So there are so many issues when it comes to security as well. So that is also an important criteria on how a network performs. So when we look at the network, we have the three main criteria. We have three main criteria. One is the performance, two is reliability, three is security, and within which we have so many other things as well. Now, there are different types of connection, and here I have listed. One is point-to-point connection, the other is multi-point connection. Now, what is, this type of connection is when two or more devices are connected through a link. This communication partway to transfer data from one device to another. So for the sake of understanding or visualization, it is simple to imagine that any link as a line drawn between 2 points for communication to occur. This device must be connected in some way, as we said in the beginning. So this connection between two devices, two or more devices, can be in two ways. It can be with point-to-point connection, or it can be through multi-point connection. So a point-to-point connection provides a dedicated link. Remember that this link is dedicated. Okay, it provides a dedicated link between the two devices. This device and this device have a dedicated link. That means this particular link is not shared by any third, fourth, or fifth devices. It is shared by station A and station B only. So that is what we call it, a point-to-point connection. So most of these connections use the actual length of the cable to connect the two ends. But there are other options such as microwave or satellite links. When you change the television channel, for example, with your remote control, you are having a point-to-point connection between the remote and the television system. Otherwise, what will happen is that whenever you are living in a flat, you are separated with your neighbors with a wall. Whenever, if it is not point-to-point, then you might end up, whenever you change channel, you might end up changing the channel of your neighbors. So for this kind of thing, we use point-to-point connection, so that that link, wire or wireless, is used between the devices which is sending and receiving the signals. Now the next one is multi-point connection. Sometimes this multi-point connection is also called multi-drops, multi-drop connection. Now this is where more than two or more devices share a link. If you look at this, that this is the link. This is a single link. It is shared by 1, 2, 3, 4. So we have 4 devices sharing one link compared to what we have in point-to-point. So this is called multi-point or multi-drops. In this environment, the capacity of this channel is shared. It can be shared temporarily. That means that when 1 is using it, 2, 3, and 4 will wait. When 2 is using it, 3, 4, and 1 will wait. That is temporarily. Or it can be through spatially. That means the capacity of this cable is divided into so many spaces, and then each one is using their own spaces. So that is how this multi-point works. Now we know there's 2 different types of networks. Now coming to physical topology, the term topology refers to the ways in which a network is laid out physically. That means you set up a network, and how are those networks laid out physically. So that is the topology of a network, physical topology of a network. Now, there are 4 basic topologies. That is mesh topology, then you have star topology, bus topology, ring topology, and hybrid is, we call it hybrid topology when the network is not just ring or bus or star or mesh, but a combination of 2 or more of this topology. Then we call it hybrid topology. So let us look into these network topologies. Now the first topology we picked up here is a mesh topology. Now in this topology, as you can see that it is a point-to-point connection connecting all of the station in this network. So every station, this and this and this is connected, this and this is connected. Here, for example, if we say this is A and B, B, C, D, E. So if you look at that, each one of them have a dedicated connection. So that is what a mesh topology looks like. So you will have, if you have 5, in these cases we have 5 devices connected, then you will see that accordingly the number of links are also there. For example, this station E has 1, 2, 3, 4. So it has to have a connection with the rest of the 4. So this was this is what we call mesh topology. Now, mesh topology has several advantages compared to other topologies. One of it is that a dedicated link guarantees that its connection can carry its own data. For example, if you want to send from something from A to E or A to B, then they have their own dedicated connection. So it is not sharing. This dedicated connection is not being shared by any other connection. So the link did not be shared. The second is that it is very robust. For example, let us say that this A to E is broken down or A to B is broken down, and the rest of the links still works and the rest of the network still function. Then the other network, the other advantage is that there is privacy or security. That means what the data that is being sent between A and E is not known by B, C, or D, or the data which is being sent between A and E is not known to, or it doesn't have to pass through C, D, or E. So there is maximum privacy is there. Then another major advantage is that identification of faults. Now, if there is a fault in the network, you can easily make it out whether the fault is between A and E or A and B. So that is one of the major advantages of the mesh topology. But there are several disadvantages as well. One of them is that you need n number of input-output ports. That means, suppose you are connecting to 100 devices in your network, then you will end up having 100 input-output ports. Let us say this is the back of the computer devices, which is in mesh topology, and it has to be connected with 100 computers. Then you need to have input-output ports here, 100 input-output ports. Then only you can have a mesh topology. So that is one major disadvantage. Installation and reconnections can be difficult. Then the bulk of wire. See, if you look at this, the number of wire which has to be handled is quite bulky. So when you are running these kind of cables, even if the cable may be small, but when you run so many cables on ceilings and walls, it can really be a problem. So the other advantage is that, this input-output ports and the cables can be prohibitively expensive. Now, coming to the next topology, that is star topology. In star topology, what happens is that each device has a dedicated point-to-point connection. Okay, it is point-to-point connection, but it is connected through a hub or a switch. So the connection is based on this hub or switch. So these are directly linked to one another. It is still a direct link, point-to-point connection, but through a hub. Unlike the mesh topology, this does not allow direct traffic between devices. Now, this hub controller act as an exchange. If one device wants to send, now if we say this is A, B, C, and D, if A wants to send something to B, then this particular hub will control that A is going to send a message to B. So that is how it works. Now, if one device, now star topology is very, comparatively less expensive to the mesh topology because it requires less cable and then it requires less input-output ports. Now, this factor also make it the installation and configuration in buildings and so on much more easier. So you need far less cabling in the house, and you can be able to move, delete one connection or more that easily. Now, the other advantage is that it is robust. If one connection fails, for example, this link fails, the rest still works. The only this also helped in easily identifying the fault. Where is suppose if a link this is broken, that is the link which is connecting A is broken. It's very easy to identify where the problem lies. So as long as the hub, this is very important, as long as the hub is working, this star topology will run. The problem is that there is big disadvantages when the hub is not functioning, or when the hub is down, then the whole network collapses. So that is the main disadvantage of this star topology. Now, star topology is very popular in local area network, which we are using within building, or within building blocks, or within lab, and so on. So it is very popular in local area networks. Now, the next is bus topology. Now, this bus topology is a multi-point connection. As we said in the beginning, that a single wire or single cable is used by multiple number of stations, devices. Now, a bus topology, in bus topology, one cable, in this case, this is the cable. This one cable act as the backbone. And let us not forget that there are cables here as well. These are also cables. So, but one cable act as a backbone of the network. And there are other cables which we call it drop line. Okay. Yeah, drop lines. So drop lines are used to connect between the backbone cable and the devices. So the nodes are connected to the bus cable or the backbone cable by a line, drop line. And we have these small devices here. These are called tap. So a tap is nothing but a connector that is either spliced into the main cable, or it is or the seating of the cable is punctured to create a contact with the metallic core of this backbone cable. So there are different ways of connecting. So a signal travels along this backbone. Now, chances are that when a signal is traveling along this backbone, that it can after it passes a certain length, it can become weak, and then ultimately what happens is that the signal can become heat, can transform into heat. So the weaker it becomes, the further it goes, it can become weaker and weaker. So for this reason, there is a limitation on the number of taps that a bus can support in between a particular distance. Now, the advantage of a bus topology is that it is easy to install. So the backbone cable can be laid and then connected to the nodes by a drop line using various drop lines of various length. So you only have to lay the backbone cables in a proper places. Now, that is the entire cable, the backbone has to be stretched. Now, the problem is that if the backbone fails, then in this bus topology, then the network collapses. Another disadvantage is that it's usually designed to be optimally efficient at installation. Therefore, it's difficult to add new stations or new devices, because You have to, I mean, the way the connection is done. So bus topology has difficulty accommodating new connections. Next, we have the ring topology. So in ring topology, this is a point-to-point connection. Okay, point-to-point connection. Now, ring topology has a dedicated point-to-point connection, and only two devices on either side of it. That is between, let us say, this is A, B, C, D, E, and F. Okay, so the connection is between A and B, B and C, sorry, A and B, B and C, C and D, D and E, and so on. So a signal passes along this ring in one direction. So until it reaches the destination. Now in the ring, there are repeaters. These points are repeaters. The points we have here are repeaters. Just a moment. Let me change the color of the pen. Okay, these are repeaters. So as it moves, let us say that it goes, I mean, A wants to send a message, then it has to go from A, B, C, D. For example, the destination is D. Then as it passes through every station, then these repeaters repeat the signals, and then it strengthens the signals as it goes on until it reaches the destination. So that's how ring topology works. Now, whenever a device receives a signal intended for another device, as a repeater regenerates a bit and passes them along. For example, A wants to send something to B, D. Then, as it passes through B, B will see whether the message is meant for him or meant for its B. If it is not, it will regenerate or re-strengthen the signal and then pass it on to C. C will examine the message or the signal, and then since it is not meant for C, it will pass it on to D. So that is how it works. So the advantage is that this is relatively easy to install and reconfigure. Now the device is linked to only its immediate neighbor. A is linked to B, F is linked to A, so immediate neighbor. Now the constraint is that the media and traffic consider maximum ring length number of n number of devices. That is that you cannot go beyond a certain number of devices. Now, fault isolation is simplified. Generally, a ring signal is circulating all the time. One device does not receive signal within a specified period, it can use an alarm. Then it alerts the network operator that there is a problem in the network. So that is how the fault can be identified. Unidirectional traffic can be also disadvantaged. A simple ring, in a simple ring, a break, if there is a break, for example, between C and D, then there can be no communication. Communication becomes a problem because it goes in one direction, clockwise or anti-clockwise, it goes in one direction. Therefore, whenever the signal passes through where the cable breaks, then the signal will not be going further. So this ring topology used to be very popular in IBM's local area network. And the next one is hybrid topology. As we said, I'm not drawn any topology here. When you have a combination of, for example, mesh plus star, or you can have a star plus bus plus ring, then when you have this combination of network, that is what we call it hybrid topology. Now, coming to categories of network. So there are different categories of network. Now, computer networks are created by different entities. So today, when we speak of a network, we are generally referring to two primary categories. That is local area network and wide area network. These are the two primary networks which we are often referring to when we talk about networks. Now, there are so many other networks also, but these are the two basically popular networks. Usually, this network is often determined by the size, the sheer size of the network, how big is it, or for example, a LAN, local area network, cover miles which is less than 2 miles, or a wide can be a worldwide network, so that kind of thing. Or that between these two, you can call it, suppose it is within the city limit, you can call it metropolitan area network or MET. So these are the different categorization. Now, local area network is usually owned privately, often in a single office, building, or campus. Depending upon the need and the type of technology, LAN can be only 2 PCs. Okay, 2 personal computers can be a LAN, or 100 computers, 100 PCs can form a LAN, depending upon the requirement. Usually, it is confined to one building, or it can spread out to a company. And today, the local area network size can be few kilometers. It can be as big as a campus-wide network. So that's why we call it campus area network. So these are allowed, local area networks allow to share resources between personal computers or workstations. So as a common example found in many business environments are like work groups and so on. Sometimes they have a common server or common storage server. I mean, such are the things in which local area network is used. Now, initially, local area network used to be around the capacity, rate of transfer between the devices used to be 4 to 16 MB per second. Today, it has the speed is around 100 to 1,000 Mbps. That is quite fast. So we will be discussing in details in the later classes in details about what is a local area network and the details about the technology behind a local area network. Then coming to wide area network, this is basically very wide area network, like the World Wide Web itself, as I said, can be a wide area network, or it can also be something like a cable network. Okay, so comparatively, these wide area network use systems like switches in between. So you have N system which are connected to switches, and each switches, for example, these are switches. Okay, then these switches are interconnected in a mesh topology. Then we have N computers, N computers connected to the switches. So these can be extended. Sometimes this it can also be they can use a point-to-point connection, as in connection using a modem. Okay. Then finally, as we said, this can be as wide area network can be as big as a state, a country, or the world itself. Then coming to metropolitan area network is basically something which is between local area network and wide area network. So metropolitan area network can be a network, TV network that was designed, cable TV network within a city. Your local cable TV provider can be called a metropolitan area network. So these are some of the different categories of network. It is not that necessary that the categories of networks are limited to only these three. We are just giving, I'm giving you some idea that there are different categories, and the number of the categories can be much more than this, just to have an idea of how different categories are there. I'm giving you these 3 categories in order to understand the categories of network. So with this, we have come to the end of your today's lecture. So we'll have the remaining, the next class in the next video as soon as possible. So thank you very much for being there and listening till the end.
Thank you, sir.